what we're going to chat about today is the Cartesian plane. So some of you might have heard of the Cartesian plane, some of you might not have, but the Cartesian plane is basically what we use to plot points on and to identify where points sit on a Cartesian plane. Now, if we just think about what this means in like the real world, like real world examples of a Cartesian plane, all of you do geography, all of you do map work in geography. And so when you think about like coordinates and lines of latitude and longitude, that is like a Cartesian plane. We know that lines of latitude and longitude and coordinates allow you to pinpoint a very specific position on a map. So for example, here, if we wanted to, if we look at this map, if we wanted to pinpoint where Mount Everest is in the world, we can read off its coordinates, latitude and longitude, north, south, east, west, and we know exactly where it is on the globe. And that is essentially what the Cartesian plane does for us. It allows us to pinpoint or locate exactly where a specific point sits on a Cartesian plane. Now, obviously, this is why I said don't screenshot this. We are not going to do coordinates like in geography. We're going to apply it to maths. And so when we start to apply this coordinate system or this Cartesian plane to maths, what we are able to do is we're able to plot points, as we're going to practice today. We're then able to start drawing shapes on a Cartesian plane. And this is where we can then start to transform the shapes by rotating them or reflecting them or translating them. So we can use our Cartesian plane to move shapes and change shapes around. What we're going to have a look at specifically is being able to draw graphs. So being able to represent a relationship between an input and an output through a graph, so visually represented. We can use these for geometry. There's so many ways that we can use the Cartesian plane in maths. So obviously we're going to start off slowly just by sort of doing some general stuff, but you're going to see how often we actually use the Cartesian plane throughout multiple sections in maths. And you're going to use it from grade 8 until matric. Even if you decide to do maths lit one day, we still use an X and a Y axis in maths lit. We still plot graphs with an input and an output value. And so it's going to be with you basically for the rest of your high school career. Alrighty, so before we start getting into plotting points and reading points, we just need to know some important features of the Cartesian plane. So this is now where, excuse me, where we'll take screenshots, but let's first put some notes on here and then you can take a screenshot, or you can do the notes along with me and then, yes, whatever you miss, you can screenshot. So the very first important thing about the Cartesian plane is the fact that we have got two very important lines that we need to have here. So I'm just going to go over them. No, I'm not, because apparently I'm just losing my mind. We've got two very important lines. We've got this vertical line that's drawn here, and we've got this horizontal line drawn here. And basically what they form is a cross. They meet at 90 degrees. They're perpendicular to each other. And these are what we call our axes. So the horizontal, so the one that goes left to right, whoops, is our x-axis. Okay, this is the horizontal axis. You don't even need to label horizontal. I'm just reminding you that it is the horizontal one. And, excuse me, the vertical one, so the one that goes up and down, is your y-axis. So those are the first two very, very important features of our Cartesian plane. You have to have your two axes, x and y, in order for you to be able to plot coordinates. Okay, I don't know who's not on mute. Just remember, guys, if you aren't on mute, make sure you are. So that's the first thing. The next thing is then like the more specific features of our Cartesian plane that we're going to start using for being able to work with coordinates. So again, Zoom user, this is a maths class. I've just related it to an application in geography, but we are in a maths class. Okay. So guys, what you need to remember, and those of you who have done this before will hopefully remember this, we need to remember that coordinates are written in a very specific format. Coordinates give us a specific place on the x-axis, so the horizontal axis, and a specific place on our y-axis, which is our vertical axis, where we can locate a point. So coordinates are always in terms of x and y, all right? And so because of this, it's very important for us to be able to locate specifically on each of those axes where a point sits. Now, what that means is that on our axes, we now need to have some labels so that we can pinpoint a specific point or a specific coordinate on our Cartesian plane. Now, the first very important point that we need to know about is this one here where the two axes actually meet. So where they cross or where they intersect with each other, we have a special name for this point, and this is the point 0, 0. Okay, now I'll explain this now as we start to talk about our axes. But you can almost think of this as like the starting point of your axes. From there, your y-axis can go up or it can go down. From there, your x-axis can go right or it can go left. It's sort of the starting point from which we can now work with our Cartesian plane. Now, this point, like I said, has a special name for it. This is called the origin. Now, again, you never have to write down origin on every single set of axes that you use, but it is important to know what it is, because when I say, look at the origin, or when I say we are now at the origin, it's important that you know which point I'm talking about, and you know that it's at 0, 0. So those are sort of the basic and important features of our Cartesian plane. From there, we now need to be able to, like I say, plot coordinates. And in order for us to plot a coordinate, we actually need to have values on our axes. Just going to take a quick second. Penyo, I do see the name there. Unfortunately, there's 2 Zoom users, so I don't actually know which is which. I don't know if Yolanda can maybe help me out here, but I don't know which is which, but I will try and remember to not call you Zoom user in future.
Yeah, we will always refer to Penyo, and you'll let us know whether it's not you or it's you. Sorry, teacher Sam, I just wanted to say to the newcomers who just joined now, remember that I am just not disabling the meeting room, and I'm making people wait there because they are late and I need to give them instructions before they come in. So please bear with me if you're joining in with another device and you're using another device here. I saw someone talking to us about that. So thank you so much.
Cool. Sorry about that, guys. There was noise outside. I had to ask for them to stop. Okay, so the next sort of important feature we need to have is the fact that we need values, because in order for us to plot an x and a y, we know that x represents an input value and y an output value. So we need to have numbers. Now, this is sort of where the origin and why the origin is quite useful to know where it is, because we need to imagine these axes like number lines. That's basically what they are. You've got a number line that runs horizontally. You've got a number line that runs vertically. So if we just work with the horizontal one first, because that's more like the type of number line we're comfortable with. If we think about a normal number line, if we start at 0, so if we start at the origin, if we move to the right, we're now going towards positive infinity. So all of these values to the right are now positive, and we are increasing those values as we move along. Okay. And then if we were to go to the left of our starting point, so to the left of 0, we're now going towards negative infinity. So all of these values to the left of our origin are negative. Now I'm choosing to decrease and increase in steps of 1. So 1, 2, 3, 4, 5, and -1, -2, -3, etc., etc. You don't have to go in steps of 1. Usually we do, but you can go in steps of 2 or 5 or whatever, but sure it's consistent. You can't go 1, 2, 3, 7, 20, 22, 23, 24, 30. It has to be consistent. So if you're going to go up in twos, you go up in twos for the whole axis. But generally, we go up in ones. Right, so just to remind you, if you go to the right, your x values are positive. If you move to the left, your x values are negative. Right, so from the origin, if you go right, all your x's are positive. If you go left, all your x's are negative. Now, the y-axis is also a number line. It's just going up and down. So in order for us to decide where should the positive and where should the negative be, just think about it logically. If we go up, we're increasing, so we're getting greater, so positive. If we go down, we're getting less than, so negative. So as we move up from our origin, we're increasing, so 1, 2, 3. Again, I'm going up in ones. But if I now go down, I'm working with negative y values. Right, and so once again, it's very important that we know where values are positive and where values are negative, because when we start to plot coordinates, we need to know, is the input, is x positive or negative? Is the output, is y positive or negative? So just a reminder, when we now go up our y-axis, the y values are positive. When we go down our y-axis, our y values are negative. All right, so when we are starting to draw axes for ourselves, sometimes you will be asked to draw your own axis to then use. We need to know where the value should be positive and where they should be negative. Right, guys, so I'm going to stop here in case anyone wants to take a screenshot. I'm also going to stop here in case anyone has a question specifically related to what we are doing. Those of you who have joined late, please don't ask me questions of repeat or I don't know what's happening. You need to go and watch the recording. But anyone who has a question on anything I've said here, now is the time to raise your hand. Right, I'm just waiting for people to take screenshots. So if you don't have questions, that's obviously absolutely fine. I'm not going to force you to ask me a question. And guys, do remember that the chat is there for questions. So if you have questions while I'm speaking, put it on the chat. Nice, guys. Alrighty, so what we're going to practice now is reading coordinates off of a Cartesian plane. Again, you're welcome to draw this if you want, but I would maybe just follow with me and then take some screenshots at the end because there's a lot going on here. And I don't expect you, we're not going to do all of these points. Otherwise, we're just going to be here forever. But it is important to practice. So we're going to do 1 or 2 together, and then you guys are going to give me some. You're going to try some by yourselves, but we're going to go along. Alrighty, so what we want to do here is we want to read coordinates off our Cartesian plane. I'm just going to do a little reminder. Coordinates are a set, coordinates, I have to remember how to spell it, are a set of ordered values. And it's very, very important that we remember that they are ordered. Right, so what I mean by that is a coordinate will always be listed as the x or the input first, and then the y or the output, always, right? Think about it. X must go in and be applied to the rule before you can get an output. We need to have one or the other in order to do it. So x comes first, and if you just think alphabetically, x is first, and then we get the y value. So when we write down a coordinate, we always want to write down the value of x first, and then the value of y. So if we go and have a look at, and we're just going to start with the first one. So if we go and have a look at A, so here's coordinate A, we want to read off its coordinates. Now, in order to do that, what we want to do is we want to read down to our x-axis. So we want to see where does it line up with the x-axis, and we can see that this a value lines up with x equals 3. And then we want to read across to the y-axis to get our y coordinate, and we can see that that is 1. So this coordinate for a is at 3, 1. We can identify, or we can specifically pinpoint exactly where a is. Now, this is important, guys, because I won't necessarily always give you a diagram. I might just say to you, A is the point 3, 1, and expect you to draw it, which we're going to get to just now. So you need to be able to look at a coordinate and know where it sits on the Cartesian plane. And like here, you need to be able to look at a coordinate and know, or you need to look at a point and be able to read off its coordinates. All right, so if we go to coordinate B, we're going to do another one together before I let you try by yourselves. So if we go to coordinate B, here we are in green. X first, so we read down to the x-axis. We can see that x is 1. I'm just going to write it on the side here. And then if we read across to the y, we can see that y is 3. So we know that our coordinate of B is 1, 3. Right, so again, we read off x, we read off y, and we then know exactly where it is on our Cartesian plane. And this is why I likened it to geography. That is what a coordinate system does. It gives you a specific point, north, south, east, west, however many degrees, and you know exactly where on the atlas or where in the world you are looking. All right, so guys, please listen to my words. All I want right now is for you to give me coordinates of C, just C. We're not going to do all of these, so don't rush and do everything. I just want C, and I want you to put it in the chat for me. So in the chat, I should be seeing in a second or two coordinates for C. Please remember, coordinates need to be written out with the 2 round brackets and a semicolon. If you use a comma, that can imply a decimal. So we need to use a semicolon. 2 dots can imply a ratio, and we're not working with ratio, we're working with coordinates. So semicolon and 2 round brackets. Remember, it is x first and then y. Okay, so I'm just giving everyone a second. Give it a try. Again, x first and then y. Good, grade 8. Okay, so if we go to the x value for C, we can see it's at 6. And the y value, when we read across, is at 2. So we have got a coordinate of 6, 2 for C. Excellent, guys. So now I'm going to give you a couple that I want you to try. And I want you to put them in the chat for me. And then I'll tell you if and when, well, I'll tell you when you can raise your hands. But for now, all I want are the following coordinates written down in the chat. So I want you to do J. I want you to do K, P, and M. Actually, and G. Sorry, I've gone alphabetically. So G, J, K, M, P, L, M, N. Yeah, M, P. I'll write a list down on the side because clearly I don't know my alphabet off by heart. So G, J, K, M, and P. Those are the coordinates I would like from you. I want you to put them in the chat. And remember, coordinates, X first and then Y. A reminder to everyone who's late, again, I'm not repeating anything. Unfortunately, because you were late, it's now your responsibility to go and watch the video online, but the video will be uploaded for you. So don't stress, just make sure you do go and watch the video. Right, so guys, like we're seeing here on the chat, the letter and its coordinates, letter coordinates, so that I know which coordinates you are talking about. Keep them coming, guys. You're doing really nicely. Well done. Tea is ice cold.
Ugh.
And just a reminder, guys, brackets and semicolon in between, and it is X first and then Y. Keep those answers coming. You're doing really nicely. I'm liking that some of us are attempting G. Well done. And M, well done. I know those are slightly harder, but you can do it. Oh, gracious.
Sorry, I'm just putting it out there for everyone to know that the reason you are having a sort of a problem like logging in is because I'm making you wait at the waiting room since you are late, so that you can get instructions first before you can join in. Okay, so next time, please everybody, let's join early. Will be nice.
Agreed. Okay, grade 8s, I'm going to give you another minute, and then I'm going to want some answers. And don't stress, I will wait when we're done for you to take screenshots just in case you haven't gotten all of this down. And it also means that you then got some coordinates that you can go and practice getting the coordinates for. Guys, just remember this round brackets. We don't use square brackets and we don't use the squiggly brackets, okay? We use round brackets for the coordinates. The other types of brackets or parentheses, they mean something else when we start dealing with them in maths. So round brackets for coordinates. And remember, if you have joined late, we're not restarting, we're not re-explaining. You need to go and re-watch the video. Excuse me. Right, guys. You can raise your hands if you would like to give me an answer for any of these coordinates. Please remember that there are 76 of you and we are asking for 5 coordinates. I will not get to everyone. I try and give everyone a chance, and especially when I see new names, I try and give people a chance. Mlemo, which one would you like to give me?
M.
M. Okay, cool. So tell me the coordinates of M.
The coordinate for X is -6
Good.
and Y is 0.
Excellent. Well done. So guys, I'm just going to take a second here because this is such an important one that we need to understand. So if we go to M, here's M, we can very clearly see that its X value is -6. We've moved along to the left and we're at a point left. However, this point has not moved up or down. It has stayed at that 0 point for our y-axis. And that is why the y coordinate is 0. It hasn't gone up or down. Right, very, very nice. Well done. So that was M for us. Whoopsie daisies. Bonolo, would you like to give us another one? You can choose.
Ma'am, I would like to give K.
K. Okay, perfect. So what is K?
So ma'am, the x-axis is -3
Good.
and the y-axis is 2, +2.
Perfect. Well done. And again, guys, make sure you've got the -3 and the +2. It would mean different things if we didn't have those signs correct. Very, very nice. Sianda, would you like to give us another one? Don't know why I'm shouting.
Yes, ma'am.
Right, tell me.
P.
P. Okay, cool.
So the x-axis is -3 and the y-axis is -4.
Okay, so x-axis, read up, is -4. And then y-axis, we read across, oopsie, is -3. I don't know if I maybe just misheard, but -4, -3. Good. Right, Ashley, would you like to give us J or G?
Ma'am, I'll give J.
Okay, perfect.
The x-axis is 5 and then the y-axis is -3.
Excellent, well done. So 5 on the x, -3 on the y. Very, very nice. Well done. Kagiso, would you like to give us G?
Ma'am, the x-axis for G is 0 and the y-axis is -1.
Excellent, well done. So guys, that's a similar conversation to what M was, but now it hasn't moved left or right. It's stayed at that 0 position, hence why x is 0, but it has moved down 1. So that's why y is -1. Okay, very nice, grade 8s. Well done. And well done, everyone putting answers on the chat. Excellent, excellent. So please take your screenshots. If anyone has any questions at this point, now is the time to raise your hand and ask me. Otherwise, you guys have done really nicely. We're going to take a little break before we carry on and try and read some coordinates off. Okay, so any questions, you're welcome to raise your hand. Otherwise, you're taking screenshots. And remember, guys, we haven't done all of the coordinates. So from your screenshot, you can now go and practice reading of coordinates for the ones we didn't do, like L, N, Q, H, I, etc., etc. I'm so sorry. I didn't actually see your hand at all. Otherwise, I definitely would have picked on you because I don't think I picked on you before. So next time I ask for hands, please do raise it. Don't know why I didn't see your hand there. Okay, guys, last 2 seconds. Screenshots. Right, brain break. Well deserved.
Well deserved, guys. Well done. And the joke also, yeah. Read the joke so you can laugh.
Right, so the joke, for those of you that maybe can't see, it says, why should you never talk to pi? Because, whoops, because you'll go on forever. Pi, Alrighty, guys, those of you that are new to the brain break or don't remember, because we haven't had one in a while, remember, I just want the answer of that last equation in yellow. So you need to figure out the value of the little fish flag things, the popcorn and the sparklers, in order to work out the value of the last equation. I am going to help you for a second here, though, because it isn't super clear. There are 2 sparklers in this last image, so just be careful. Right, if we don't get the joke, remember pi never ends. Pi is a number that, or where the decimal just keeps on going. It goes on for infinity. So that's why it's saying he'll just go on forever, because pi as a decimal keeps going on. Yo, Zintle, how? That was so quick.
Wow, it just looks like
genius.
as if Zinhle was like on the other class, because that was just so quick.
I know.
That was the quickest brain break ever.
Yo, Zintle, can you put your hand up and explain for us? Zintle, you want to put your hand up?
Well done, Chipo. You also got it right. Well done, Teto.
Yeah, Chipo, do you want to raise your hand and tell us?
Renelwe also, Tando also. Well done, guys.
Because now we're picking on you, because now you might just be copying an answer. So I want to know how you got those answers. So if anyone can raise their hand and tell me why it's 109, thank you, Teto. Okay, Teto, explain it for us.
Hello, ma'am. Ma'am, can you hear me?
I can indeed.
Yes, ma'am. Okay, ma'am. Ma'am, so for the fish, ma'am, the answer I was supposed to be working towards is 27. And since there were 3 of them, I said 27 divided by 3 is 9. So I ended up with fish being 9.
Good. So each of these fish flag, weird things, whatever they are 9. Good.
Ma'am, so then for the second one, it would have, oh, you've already written it down. It would have been 9 times 9, which is 81.
Good.
So then 81 minus 86 minus 81 is 5. So I ended up with popcorn being 5.
Good. And I just want to interrupt. Guys, remember BOD math. So that's why Teto started by saying 9 times 9. The multiplication has to happen first. Okay, Teto, carry on.
Ma'am, then for the third one, it was 105. So I minused the 5 from the 105 because I was working backwards. So I ended up with 100, and I just automatically knew that 10 times 10 is 100. So I knew that the sparkle thing was 10. So the final sort of sum would have been 5 times 20 plus 9.
Good. So guys, it's 20 because there's 2 sparklers, and if 1 is 10, 2 is 20. So Teto, what do I do first? Times or plus?
Times.
Good. And what's 20 times 5?
It's 100.
Good. That was a weird block that I drew. And so 100 plus 9 is that answer Teto gave us of 109. Excellent. Well done. Speed.
Nice, my people. Well done, guys.
Very nice, guys. I think that was probably a record for a brain break. And then someone could explain it. So well done. Alrighty, so brain break over. Well done. We might even end a little bit earlier because you were so quick, but let's see how we go. Righto. So don't worry, I did write down 2 sparklers there, but I know it wasn't super clear. So in future, just always listen up and have a look out, because if it isn't clear, I will try and write it there for you. Right, guys, so whoopsie daisies. Right. What we also need to be able to do, so what we know how to do now is read coordinates off a Cartesian plane. What we need to be able to do is also put coordinates onto a Cartesian plane. Oh, gosh. So in order for us to do that, we again need to obviously have those important features of our Cartesian plane. Here I've been quite nice, and I've given you the X, I've given you the Y, and I've put the numbers on. You sometimes need to draw that for yourself. So just remember all of those features that we spoke about. But like I said, you need to be able to look at a coordinate that's given to you written down, and you need to be able to plot it on the Cartesian plane. I'm going to do 1 or 2 with you, and then I'm going to get some of you to explain a couple. But let's just start with A. Okay, apparently this is going to fight me. So A. Remember, guys, a coordinate is X and then Y. So if A's coordinates are -2, 1, that means that the X value is -2 and the Y value 1. So that's essentially what we do. I always start with X. X comes first, it just is logical. So X is -2 is over here on our X axis, and Y is 1 is over here on our Y axis. Now, in order for us to plot that point, basically what we want to do is we want to travel vertically up and horizontally across until we meet. Where we meet with our X and our Y, that is where we get our coordinates. So this is now the coordinate A, -2, 1. And we have been able to plot that very specific point for A at the point -2, 1. Right, so when we plot coordinates, X, Y, where they meet, that is where we draw our point. So let's try another one together. We're going to try C. So C is at +4, +2. again, we go to the x-axis and its value is 4, and the y-axis, its value is 2. So we go up where we're going to get 4, we go across where we get 2, and where they meet each other, that is where we get our coordinate C4, 2. Now we don't draw in the dotted lines and stuff, we just plot the little point, so that's why I'm leaving the little point. That's all we have to plot. If you need to draw in pencil the dotted lines to get the point accurate, obviously by all means do that. But all we actually want is to see the point, the coordinates. All right, so what I want you guys to try for me, and I'm going to let you have a think and then someone's hopefully going to explain it, is where would we plot point D? So have a think. And then if you would like to try and explain to me how to plot point D, you can raise your hand and try and explain it for us, where we would put it. Okay, Kakiso.
Ma'am, can I see?
Yep.
Oh, ma'am, since it's positive 5 and negative 1, then you have to, for your y-axis, it's by 5, and for your, no, for your x-axis, sorry, it's by 5, and for your y-axis, by negative 1.
Perfect. Excellent. And well done on catching that mistake there, that swap. So guys, exactly. X is 5, y is negative 1. Where they meet, we are going to plus our point, D5, negative 1. Right, so in that example, again, very, very important that we know where X and where Y are. If we don't, then we've got a bit of a problem. All right, so I'm going to see who can maybe tell me where we could plot E. So let's see who can maybe explain for us where, oh gracious me, where E would go. Teto, I see your hand is already up. Would you like to explain E?
Yes, ma'am.
Okay, I'm ready.
So ma'am, for E is 2.5 and 4. So this sounds a little okay. So ma'am, 2 on the x-axis going down to the right side. 2 or 3, you'd have to stop like right in the middle.
Okay, Teto was lagging a bit, hence why I put off my camera. But from what we got so far, 2.5 is exactly halfway between 2 and 3. So this is a bit of a harder coordinate to point because it's to plot, sorry, because it's not on one of those grid lines. It's halfway between, but that doesn't matter. We now know where X is. We know that Y is at 4. So we go up. Remember, exactly halfway. We go along 4, and where they meet, we're getting the coordinate E, 2.5, 4. All right, so just because we all of a sudden have a fraction, it doesn't mean that we now need to panic. We just now need to think very clearly, where would it sit between the numbers or along the number line that we have drawn for ourselves, which are our axes. Okay, so 2.5, Teto, don't worry, everyone has internet problems at the moment of load shedding, so don't you stress, you explained it beautifully. So guys, fractions shouldn't scare us. We just need to be careful of what they're telling us. Right, who would like to explain for me where we would plot? You can raise your hands. I'm gonna find a color that we haven't yet used. Let's go pink. Anyone want to explain to me where I would plot point G? So G is at 0, -1. Kakizo?
Ma'am, since it's positive 0, it's probably still stay in the middle, ma'am, for your x-axis, and then for the -1, then you have to go down to the y-axis.
Perfect. So guys, that 0 is your x. It means that you haven't moved left or right. So it's going to stay at 0 on x. And then exactly, y is -1. So we go down, and where we meet at -1, that is where we plot our point G0, -1. So hopefully what you're starting to see from this example and the one above, whenever there's a 0 coordinate, we need to just think carefully about where it's going to sit. So if we now compare G to, say, for example, the coordinates J. J is now the coordinate -4, 0. So let's just get our green here. So J is -4, 0. So we go to -4 on the x-axis. Y is 0. So we're not moving up or down. We're staying on that axis. And so the point for J is going to be plotted on the x-axis at -4. And so if we just compare what we saw in J and G, getting excited with my highlighters here, we can see that when Y is 0, we end up sitting on the x-axis, and when x is 0, we end up sitting on the y-axis. Now that's not super important to know right now. It's just like quite a cool relationship that exists with our input and outputs. And it is going to become quite important, this idea of where x is 0 and where y is 0, when you start really getting into graphs in grade 9 and then 10, 11, 12. So it's just like a cool pattern, a cool relationship to start to see. Don't stress about it too much right now, but start to see these patterns. Start to see, okay, well, every single time that x is 0, I'm sitting somewhere along my y-axis. Every single time y is 0, I'm sitting somewhere along my x-axis. And these are now going to, or later going to be relationships or quite unique parts of a graph that we eventually plot. All right, so grade 8, you have done phenomenally well tonight. I'm really, really proud of you. I'm going to stop here in case you want to take screenshots. I'm also going to stop here in case anyone has any questions they want to ask me. There we go. Wonder Wonke, question. Did I say unmute? There we go. Wonder Wonke, you should be able to unmute yourself. Oh no. Okay, I'm going to go to Didintle. I'll come back to you, Wonder Wonke or Didintle.
Ma'am, can you hear me?
Yes.
Ma'am, how would we know which number to use? For example, -4, ma'am, because there are like 2 -4s, ma'am. How would we know which one to make the line?
I'm not sure if I understand completely. So do you mean something like the coordinates for K? No.
No, not K.
For J. Was it J?
Yeah, something like that, ma'am.
Okay, so if it's something like J, so I'm just going to take off where we plotted for J. We're going to follow the same procedure that we did. So we go to x is -4, and then we go to y is 0. But y is 0 is right here on the origin. So now when we move across to meet at -4, it's going to sit on the axis. And so that 0 means we haven't gone up or down, and so we're going to be on the x-axis. Does that make a bit more sense, didn't it?
Now, ma'am, so the one on the vertical line, ma'am, that -4, ma'am. So you don't use that one, ma'am.
You don't use this, sorry?
The vertical line.
No, because y is 0. You're not moving up or down. You're staying at that sort of origin point.
Oh, Okay, ma'am.
Okay,
I get it.
good. Well done. Okay, guys, we haven't run the poll yet, unless I'm losing my mind. So just hang 10. It should come up in a second or two. I'm just answering some questions. Wonder Wonke?
Sorry, can you see the poll on your side, Sam? Because I did run it.
Oh, no, I can't
Apparently,
see the poll.
you can't see it. Someone is wait, sorry, I just muted. Wow, I don't know.
What if, oh, no, wait, if I click on poll on my
Yeah.
thingy, it says it's been running for almost 3 minutes, but no one's answered.
Yeah, apparently it's an invalid poll and I can't change it back. Apparently, I don't know which one. End poll. Okay, no, I think I'll figure it out. Just hold on, guys. Hold on.
Oh, I see. Invalid poll ID. Okay. All right.
Oh,
All right.
no.
So we're going to give that a second. We've still got a few minutes. We'll figure it out.
Yeah.
All right. So while we're trying to sort out technical difficulties, Wonder Wonke, what is your question?
Yes, ma'am. I want to ask, is this gonna be in our June exam, like all of this?
So it depends what you've done at school. If you haven't done this yet at school, it probably won't be in your June exam. But if you have done it at school, or if you're still getting to it at school, then it will be. But at the end of the year, this will definitely be in.
Okay, yes, ma'am. Thank you.
Sure. Senzo?
No, ma'am, I was just asking, I was just trying to answer the Dinka's question, ma'am.
Oh, okay. Do you want to try do better than what I did? Because I was clearly a bit confused for a while there.
No, ma'am, it's fine, ma'am. And ma'am, we haven't started with geometry yet. So we're gonna start with it in term 3.
Okay, that's fine. I mean, like me personally, I haven't, actually I'm lying, I've done this with my kids. But that's okay. Some people do things a little bit out of order. It just now means that when you get there, hopefully you will feel comfortable with it.
Yes, ma'am.
Okay, Tsekofatso? Guys, please stop panicking about the poll. We know. Sorry, Tsekofatso, yeah?
So it might seem a little weird. So how do you see the input and the output?
Say that again. How do you see?
The input and the output.
So when you mean how do you see, do you mean like how do you read it off a coordinate, or how do you get those values? I'm just gonna unmute you again.
Yes, that's what I mean, ma'am.
Sorry?
Yes, that's what I mean about the coordinates, the outputs, because like it.
So how do you actually get the values?
Yes.
Okay, so good question. Guys, how we get these values. So these values that I've gotten here, yes, granted, I've just given you a list of coordinates, but they've come from somewhere. Now, they are going to come from when we start talking in the next lesson and later on, they now link with our pattern. So there will be a specific rule that we apply with an input and an output. And once we apply the rule, we get an output, and then we've got a coordinate. So they come from the rules that we get when we are looking at the relationship between X and Y. Very good question. Well done.